Geometric meaning of y prime equals to function of x and y. A first order ordinary differential equation given by y prime of x, which is derivative of y with respect to x, is a function of x and y. Equation number 1 has an elegant and simple interpretation. From calculus, it is known that derivative of y with respect to x represent the slope of the function y of x. Thus, a solution curve represented by equation 1 passing through a point x0, y0 must have at that point the slope y prime of x0 equal to the value of function f at the point. That is, derivative of y with respect to x calculated at the point x0 is equals to the value of the function evaluated at the point x0, y0. We can use this fact to create graphic or numerical approaches for obtaining approximate solutions to ordinary differential equations given in equation number 1. This will result in a more conceptual understanding of ordinary differential equations. Furthermore, such methods are useful in practice because many ordinary differential equations have difficult solution formulas or no solution formulas at all, necessitating the use of numerical methods. For instance, let us consider the ordinary differential equation derivative of y with respect to x equals x plus y. Equation number 2. Using a computer-aided software, we will sketch equation number 2. The computer-aided software will show short straight line segments, also known as linear elements, in the xy plane. What we obtain are referred to as a direction field or slope field into which solution curves can be fitted approximately. Because the slope field shows the direction of solution curves, it could reveal common qualities of the entire family of solution. We'll be using the program Octave 7.3. So in the command window, we're going to write the instruction for plotting the direction field or the slope field of the given differential equation. So we begin by first defining the x and y coordinates. Then we need to create a mesh grid of the x and y coordinates. So that will be given by. Then we will calculate the derivative of x and y. Then we need to plot the vector field using the quiver function. And finally, we're going to label the x's. So this is the plot of the slope field that we have obtained for the given differential equation. So what we can do is we can take the help of this plot of the slope field and then try to predict how the solution curve is going to look like. So here we see a straight line, so we can sketch a straight line. So those arrows, those moving from left to right. Similarly, we also follow along the other arrows, and this should give some shapes like as the ones we are seeing on the screen right now. When we solve the differential equation, derivative of y with respect to x equals to x plus y, we get the implicit solution x plus y plus 1 equals c times the exponential function, where c is an arbitrary constant. For different values of c, we obtain family of solution. Let's plot the function for some values of c. So here we will use Desmos to plot the solution curve for different values of c. So let's begin with the value of c equals to 0. That is going to give us the first curve. Then we will use the value of c is equals to 1, followed by c equals to -1. Then we have c equals to 20, -30, +1000, and finally -35,470. Here we can see that there is a very close resemblance with the one that we predicted using the directional field lines. This is how we can use the slope lines and differential equation to predict the solution curves.